Hello guys, I hope everybody is able to hear me out. If you can hear me, please can you give me a quick yes? Right? I hope everybody is doing fine. So today is the day 4 of natural language processing, and today we are going to cover amazing things like word embeddings, continuous bag of words, and skipgrams, which is a part of Word2vec. So, and after that, we'll again have a quiz competitions, and 5,000 rupees INR will be the rewards that will get distributed, right? So I hope everybody is doing fine. If you're new to this video, please make sure that you subscribe, like, share with all your friends. Today we are going to cite something amazing for the learning purpose, and these all sessions are definitely for community building. All the materials regarding the previous session, like day 1, day 2, day 3, is actually given in the description of this particular video. There'll be a link of the dashboard, right? So just to begin, what all things we have actually learned in the last session, if anybody knows, you can definitely let me know. And we'll just start in another 2 to 3 minutes. So what all things we have actually discussed in the previous session? Hello everyone. So hit like and please do let me know what all things we had actually discussed in the previous session. TF-IDF, bag of words, one-hot encoding, even we completed practicals, text pre-processing. Many people have also done the assignment and they have dropped me the mail, which is quite amazing. Everybody, I could not reply everyone, but yes, you have actually done some fabulous work, right? Nggrams we have actually completed and all, right? So today we are going to continue ahead and we are going to learn something more amazing like Word2vec and all. We'll try to understand. And before that, we'll also try to understand what exactly is the word embedding. Okay. So yes, let's start. Am I audible? I guess, guys. I hope I'm audible, right? Yeah. I feel I'm audible altogether. Let me hear my voice again. But I'm audible, I guess. Yeah. Voice is low. It should not happen. Let me reduce the volume if you want. Yeah, I guess now, can you give me a quick yes? If you are able to hear me out. Hello. Yeah, I'm just reducing, increasing the volume for you all. But I think now everybody is like audible itself, right? Everything is perfect, right? Okay. So let me share my screen. Please hit like, at least make it 100 before we start the session. So here is our screen. So today is the day 4 that we are actually going to discuss. So day 4, what is the agenda of this will be for natural language processing. First thing, we are going to discuss about word embeddings. Second topic that we are specifically going to discuss about is Word2vec. Okay. In Word2vec, we have two different types. One is CBOW, that basically means continuous bag of words. Okay. And the second one is something called as Skipgram. Okay. So we are going to understand both these things in terms of architecture and all. And then the third thing after we finish this is that if time permits, we will definitely do some kind of practical applications or implementation using Python. Practical implementation using Python. So all these things we are going to cover in today's session. And again, here the main focus is to understand things, in-depth intuitions. And after this, we are again going to have quiz. So the quiz will be there. The quiz, as usual, the first prize. Okay. See, whatever quiz happens, right, it will be happening based on today's topic. Okay. First prize goes with 2000 rupees INR. Okay. Second prize the person will get 1500 rupees INR, not 1000 rupees INR, and the third prize will basically be 1500 rupees INR. Okay, so we are going to have something like this, and then we're going to do it. Okay, so let's, without wasting any time, let's go ahead and let's try to quickly start the session and understand some things. Okay, so obviously in our previous session, now we're going to basically start with something called as word embeddings. Okay, I think I had to talk about word embeddings in the initial, in the initial class itself. But word embedding is a technique where I can definitely say that it is a technique. It is a technique which converts word into vectors. Word into vectors. Okay. In word embedding techniques, if I really want to categorize, so if I definitely write like word embeddings over here, usually techniques, whatever we learn inside this, are mainly divided based on two types. One is whatever things are there. Here I can basically say count or frequency. Based on frequency of words, we can definitely implement word embeddings. And second, by using deep learning trained models. Deep learning trained models. Okay. So usually word embedding techniques can be learned in this way. Now, if I talk with respect to count and frequency, obviously we have discussed many things like bag of words, TF-IDF, right? Bag of words and TF-IDF we have already discussed and we understood how to do it. Third one hot encoding, right? This also things we have actually seen, right? Now, if I talk about deep learning trained models, so here is where Word2vec will come, right? Both the types of Word2vec, specifically if I try to divide these types, that is first type is nothing but CBOW. This is nothing but continuous bag of words, and the other one is something called as skipgrams. So here these are nothing but pre-trained models. Okay, and we'll try to understand the architecture, how this training will actually happen. And again, the prerequisite is to understand at least ANN. Okay, if you really want to understand this, ANN, optimizers, loss function, and all. If you really want to understand this, okay. Then we also have different kind of Word2vec, average Word2vec and all, which we'll be discussing as we go ahead. Okay. In deep learning, whenever I really want to use this Word2vec, we have something called as embedding layers. Okay, embedding layer. So we basically create this layers, and this is specifically used for converting text into vectors. Okay, I hope everybody's clear till now. Can I get a quick yes? I hope some symbols, some smiley, something, so that you're able to understand, right? So based on this, we basically, you need to know this if you are actually learning NLP from scratch or from basics. Okay, and I hope you got an idea about what exactly word embedding is, because in an interview they may ask you different kind of questions related to word embedding, so you should be able to answer it. Now let's go ahead and let's talk about Word2vec. Okay, I'll give you an idea about what exactly is Word2vec. Okay, Word2vec. Okay. Okay, perfect. Many people are happy. Hit like. Yes. If you also want to do some super chat, thanks, do it so that I can distribute it to the people, out there through this kind of quizzes that I usually keep for 5,000 rupees. From now onwards, I'll take this live sessions and 5,000 rupees is the quiz that I'll try to give it to everyone. Now, one very important thing is in Word2vec is something called as feature representation. Okay, feature representation. Let me give you a very simple example. Okay, let's say I have a vocabulary of features. Vocabulary of features. Okay, and each and every feature we will try to denote it through a vectors. Okay, each and every feature we'll try to denote it through a vectors. Now, forget about this vocabulary also. Let's say that I have some words. Okay, and let me define some words over here so that you'll be able to understand. Let's say I have feature 1, feature 2, feature 3, feature 4, feature 5. Like this, I have a lot of features, and this is a part of vocabulary. Okay, I hope you know what is vocabulary. Okay, let's say my feature 1 is something like boy, my feature 2 is something like girl. Okay, my feature 3 is something like king, then you have queen, then you have, let's say, apple, and let's say one more feature you have something called as mango. Let's say this many number of features you actually have. Now Word2vec basically says that, and let's understand from the previous methods that we did in bag of words and TF-IDF. Some of the issues that we know in bag of words and TF-IDF is that semantic meaning is not captured, right? Semantic meaning basically means similar words, words that almost have the same meaning. Let me tell you an example. If I say honest and good, right, this both can be a similar word, right? Semantic word, right? There may be also some words like good, better, right? Both will be almost a similar kind of word. I also say it as a synonym word. There is some semantic relationship between these two, right? So whatever vectors that should be getting generated, both this word should have a similar kind of vectors, right? And this thing was missing in bag of words and TF-IDF. This was one of the major issue. Okay. The second issue is that whenever we are trying to create the vectors with the help of bag of words or TF-IDF, there was generating a sparse matrix. What was the problem in sparse matrix? Many numbers were zeros or ones. Or using TF-IDF, there was some kind of decimal values, right? Something like 2.23, 0.24 and all. Okay. This was a very big problem. And because of this, what was happening? There were huge dimensions that were created. That basically means we were having many vectors that was getting created. Now, if there are many vectors, obviously processing, model training, it will take time, and it leads to overfitting also, since you have many number of zeros and very less number of ones, right? So this was the major problem. This all problems will be actually solved by Word2vec. How it is going to solve, that is what I'm trying to explain you now. Okay. And I hope this is entirely covered in the previous class, whatever I'm actually talking about, right? Now, if I talk about Word2vec, how it is solving this specific problem. In Word2vec, what we do is that, yes, for every word, we try to create vectors. But always remember, this vectors that is getting created, it will be of limited dimensions. Limited dimension. This is the first point. Okay. So I'm just going to write again. What is the first point? The first point is that when we are using Word2vec, if you are creating features, or if you are creating vectors, or over here, it will be of limited dimensions. Limited dimension, let's say from 100 dimensions or 200 dimension or 300 dimension. Within that many number of dimensions, you will be able to represent the entire word. The second thing is that the sparsity, it will try to reduce. Sparsity is reduced in this. Now, when I say sparsity is reduced, that basically means you'll not find many zeros or ones. You'll be finding a vector which will be almost filled with different values. Okay. So definitely sparsity will be reduced. Apart from this, whatever vectors it is actually getting created, it is making sure that the semantic meaning is maintained. What does this basically mean? If I probably use these words like honest and good and convert into vectors with the help of Word2vec, then we are going to get a vectors which are very near to each other. Okay, very near to each other. So that vectors, if I'm trying to subtract it, you'll be able to see that the difference will be very less. Or I can also say that suppose I have these two vectors, which is over here and which is over here. Let's say, okay, based on this distance, we'll be able to find out how similar it is. Okay, so this will be represented by a different vector. This will be represented by a different vector. So one of the famous example that you have actually seen, right? I hope everybody have seen somewhere or the other way, right? If we take the vector of king, subtract it with man, and if I try to probably, or if you say like this, king minus man plus woman, what answer it is going to give you? If I use these vectors and subtract it in this way, I'm going to get queen. Okay. So this is how we are going to do this. And I'll show you how this subtraction will happen and how things will be represented. But definitely, if I try to apply all these vectors in this specific way, I am going to get the most familiar word that is related to queen. Okay. So how it is going to happen, I'll just explain you. Now, let me rub this. Now let's understand how these things are getting solved, like limited dimensions, how it is coming up, how sparsity will be reduced, how semantic meaning will be maintained, and all we'll try to understand. Okay. Now in Word2vec, what we do is that for every word, we represent it through some features. Or here I've specifically written feature representation. Now how? Let's say I've trained a model, okay? And this time, every word, these are my words, right? These are my features, words, boy, girl, king, queen, apple, mango, let's say. I'm going to represent this by some number of features, okay? Some number of features, okay? So what kind of features will be there? Let's see, okay? Let me give you a very good example. By one simple example, we are just going to generate some new features over here. Let's say there will be something called as gender. Gender is one of the feature. Let's say there is another feature that is going to be called as royal. Let's say there is one more feature which is called as age. Let's say there is one more feature which is called as food. Like this, let's say we have some 300 dimension features. Okay. Why 300 dimension? You can create any number of dimension, but understand with the help of this many dimensions, right, we'll be able to represent this word in an efficient way. Who is creating this particular feature? The Word2vec algorithm will be creating. It is very difficult to know what this specific feature is. Okay, what this specific feature is, because here we have a lot of pre-trained models for that. Google has actually done it with the help of 3 billion words. They have actually trained this kind of model, which I'm again going to show you in some time. Okay, but just understand, just for your understanding sake, I've written some feature representation and we are going to relate each and every feature with this. Okay, let's say now boy and gender. Okay, if I try to find out the relation between these two words, let's say I'm giving a value of something like -1 over here. Okay, let's say girl and gender. Okay, if boy is -1, then obviously girl will be 1 because it will be the opposite gender, right? Let's say king and queen. Okay, so here also we'll be assigning some kind of vectors. Let's say we are going to assign some kind of vectors. How this vector is getting assigned, I'll explain you just in some time. Let's say it is -0.93. This is 0.93. Okay, and always remember, since these are opposite genders, so you'll be having this minus or plus. I'm just giving you as an example over here. Okay, if I try to see apple and gender, there is no relation between apple and gender. So obviously this value will be somewhere 0. Okay, mango, so let's say that the value is somewhere between 0.1, 0.2, something like that. Okay, now similarly, if I go with the next feature, royal and boy, obviously I cannot say that you are a royal boy. Okay, so hardly there will be any kind of feature representation with respect to this. Let's say that the value that is getting assigned, a vector that is getting assigned is 0.01. Okay, based on this importance, and obviously this will be a trained model, okay, which will be assigning this kind of vectors. So let's say royal and girl, and again there will be a different value like 0.02. Let's say king and royal, obviously king, royal, king, we basically say, right? So here the value may be 0.95, here the value may be 0.96. Okay, here you can see that these two words are almost similar, right? That basically means we are able to capture the semantic information, right? Related information. You can see related words are there. Okay, related words are there. I'll talk about how we can create these vectors and all, and how this model is basically getting trained. But here you can see wherever they are related, right, those vectors will be almost same. Okay. Now, similarly, if I talk about apple and royal, hardly there will be any relationship. So I'm just writing minus 0.01, some vectors over here. Let's say age and boy. Okay, there may be some kind of relation or not. I'm just putting some values over here. Let's say if it is not at all related, both these words, okay, boy and age, okay, hardly you can't find anything. King and age, and obviously there will be some kind of relation, right? We usually say that, okay, the king, whenever we are saying king, the age may be a little bit high. So there will be some kind of relation, let's say 0.7. Let's say with respect to queen, it will be 0.6. Apple and mango, age can play a very important factor, right? Because if it is of maximum age, apple may get, Apple also has some kind of lifetime, right? If you just keep it like that for 5 days, 6 days, it loses nourishment, right? Or nutrients, right? So here I can basically write 0.95, 0.96, something like this. Okay. So in short, whatever things are basically getting assigned over here, right? Whatever things are basically getting assigned over here, you can see that each and every word is represented by some kind of vectors. Okay, so this is the vector with respect to boy. What is the dimension? Let's say 300 dimension, because we have trained our model which will be able to create this kind of numbers, right? So again, here you have girl, and with respect to girl, you have this kind of dimensions, right? This kind of vectors, right? Similarly, like this, you have this kind of vectors, right? Right? So I hope everybody is able to understand. This representation is basically created by the model. This feature representation is basically created by the model. Okay? I hope everybody is able to understand till here, guys. Yes? I hope everybody is able to understand till here. Can I get a quick yes if you are able to understand till here? Yeah? I hope this is pretty much easy and you are able to understand till here, at least getting an idea about all the things with respect to whatever things we are actually discussing, right? Okay, how these values are getting assigned, I'll just talk about it, how the model will get trained and all, everything. But I hope you are getting an idea about it. Now, let's see one thing. Over here, obviously, we have 300 dimension. Let's say that there is one word, okay? One word which is called as boy, okay? Let's say boy is, let's consider that it is represented by two vectors, which looks like this. Or let me give you an example. Forget about 300 dimensions. Okay. How these numbers are coming, I will just talk about it. Okay. Just give me some time. I will show you how this entire model will get trained. This value will be generated by the model. Okay. Whatever model, pre-trained models that we are using, or any model that we are training from scratch. Okay. So just give me some time. It'll all make sense. Now let's say king is represented by two-dimension vectors, which looks like this. Okay. Let's say it is 0.96, 0.95. Okay. Queen may be represented by some dimensions like this, 0.96, 0.95. Let's say we are assigning these vectors. How these vectors will get created, I'll just show you in some time. Let's say man is created by a vector which looks something like 0.95, 0.98, right? And let's say woman is created by a vector which is like 0.94 and 0.96 minus. Okay. Now tell me, if I'm representing this particular words like this in this kind of vectors, if I do this operation king minus man plus queen or plus woman, what will I get? What will I get? That basically means I'm just subtracting this dimensions with this dimension, and I'm adding this dimensions, and obviously my answer will be queen, right? Because whatever vectors I will be getting out of the result, right? Whatever vectors I'll be getting out of the result, you'll be seeing that vector will be matching this, right? It will be matching this, right? How it will be matching? Let's say there is something called as cosine similarity. Cosine similarity. I hope I have explained you this also, right? In cosine similarity, what we do is that, let's say there is two words that is represented in this way, okay? If I really want to calculate the distance between these 2 points, I can definitely use something called as Euclidean distance. Okay, I can definitely use Euclidean distance, right? Or I can also use Manhattan distance. Other than that, if I really want to calculate the distance, I can also use cosine similarity. So my distance will be nothing but 1 minus cosine similarity. Now, what is cosine similarity? If I want to explain about cosine similarity, it is nothing but we'll just try to find out what is cos theta. Theta is nothing but the angle between these 2 points. Okay, the angle between these 2 points. Let's say if the angle is 45 degree. So if I want to find out the cosine similarity between this point and this point, okay, what we will do? We will just write cos 45. What is cos 45? Anybody? Let me just Google it over here. What is cos 45? So I hope everybody have studied some amount of maths. It is nothing but 0.7071. 0.7071. Now 0.7071 basically means in this particular case, okay, it is nothing but this 0.071 is nothing but 1 by root 2, right? I guess. Yeah, 1 by root 2. Yeah. Now this 0.7071 is basically saying how much percentage these 2 points are similar, right? Now, if I really want to find out the distance between this, I will just write 1 minus 0.7071. So it will be probably approximately equal to 0.29, right? Let's say. Okay, I'm actually getting, so it is saying that, okay, the distance between this is 0.29. That basically means these are very, like, more the value towards the one, the more similar this point is. Now suppose if I may have another points which may look something like this. Let's say there is one point over here, there is one point over here, there is one point over here. Then what is the distance between these two? Because I need to find out this distance. So this is 90 degree. So if I want to find out the cosine similarity, it will be cos 90. What is cos 90? 0, right? So the distance, since it is cos 0, then what is the distance then? Distance will be 1 minus cos similarity. Cos similarity is 0. Sorry, cosine similarity. Then it will be 1. That basically means these two are like completely separate things, right? Completely separate things. Now suppose if I have one more point which looks like this, if I try to find out the cosine similarity between these two, it will obviously, what will be the cosine similarity over here? Cos 0 is nothing but 1. So can I say these 2 points will be similar? Yeah, I can say definitely these 2 points will be similar. I can also extend this line to this axis and this axis. Here, if all the points are here, then obviously my similarity will be almost 1. Here it will be 0. Here it will be minus 1. And here again it will be 0. And again here it will be 1. So if you try to calculate a distance, it is always better that if it is coming near minus 1, that basically means if there is one point over here and one point over here, we need to find out how similar this is. It will be coming towards the minus sign. That basically means it is from the opposite of 1, right? So this actually helps me to find out how good or how similar the points are. I hope you are able to understand. So similarly, these vectors, we can also do this kind of operations to find out the similar semantic meaning. Is it clear, everybody? Yes, yes, yes. Yeah, value towards 0, more similar. Value towards 1, not similar. Perfect, Prashantis. Amazing. I think you are getting the idea about it. Okay. Everybody clear? Yes, with respect to vectors and all and all. Now the question rises, Krish, how do this Word2vec actually get trained? How is this model getting created? Okay, how is this model getting created? And can you show me an example with respect to some practical application? The answer is yes. I'll try to show it to you. Okay. So should I show you one example first, or should I first of all explain you the architecture and then probably go to the example with respect to practical implementation? Tell me. Should I basically show you one practical application once, example once, or should I first of all show you the architecture of two types, that is CBOW, yes, architecture is good to know, right? Perfect. Good. I was expecting these answers from you. Amazing. Now let's go and understand Word2vec. The first type is something called as CBOW. CBOW is nothing but continuous bag of words. So we are going to understand continuous bag of words in an amazing way. Okay. What exactly is continuous bag of words? And how does Word2vec model gets trained? Let's say I have a corpus. Okay. I have a corpus. Okay. Corpus basically means a group of sentences. Now this will be my data set. Let's say this is my data set with respect to the training part. Training data set. And using this data set, I really need to create this Word2vec model. Okay. This Word2vec model. Okay. Now, if I really want to explain you this things, let's say let's take a simple sentence. I'll say that Krish channel is related to what it is related to, guys? What it is related to? It is related to data science. Okay. Now let's say I want to train a Word2vec model in this specific sentence. Okay. Word2vec I want to train. Okay. Now the first thing over here is that if I am using continuous bag of words model, here first thing is that we need to decide our window size. Window size. Okay. Let's say my window size is 5. Okay. Everybody got it? My window size is actually 5. Now what is this window size? This window size will be helpful for creating our training data. Okay. So now if I go ahead and make you understand how does the training data get created? So here is my training data. So obviously, with respect to training data, you have two important things. One is your independent feature, and one is your output feature. Okay. Now, if I'm using a window size of 5, let's say, so what it will be is that I will take 5 words. 1, 2, 3, 4, 5. Okay. This is the 5 words. Now, what is the center word in this, guys? What is the center word in this? What is the center word in this? It is nothing but is. Right? Is my center word. Now, this word I will basically say as my output word, output or target. Okay. And this word I will say it is a context word. Why I'm saying context? Because I really need to bring up some kind of context into it. Okay. Context into it so that it will be context basically means semantics, some kind of semantic meaning I really want to bring. So I'm basically writing it as context word. Okay. Very simple. Now, since we are actually creating, some data sets with respect to independent and dependent features. Now, is will go as my output feature. Okay, as my output feature. See, with respect to my first data set. Then over here, just a second. So, with respect to my independent feature, I will be coming over here. Now, my first independent feature will have words like Krish, channel. This is the context word. Okay, context word. And then you will be having from the right hand side related, and you will be having 2. Everybody understood this? How I got the first sentence? I'm taking the 2 context word. Okay, Krish, channel, related to. So this all I have actually put it in the first sentence. So this will be my input features and this will be my output feature. Everybody clear? Yes? Yes or no? Yes or no? Everyone? Yes? 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 Guys, you can definitely change window size. You can also keep it to 3. You can keep it to 4. You can keep it not 4, but always make sure that you keep it as an odd number so that you have the left context and the right context almost similar. Then I will go over here, going to the next word. Now what I'll do, I will slide my window by one more step. So now 1, 2, 3, 4, 5. What is the center word now? Okay. Why middle word is taken? Because always we need to have left context and right context must be same. Okay. Because we say that our input should always be same, right? That is the reason. Okay. Now tell me what is the center word related to this next slide? Which is the center word? It is nothing but related. So my output will now be related. And my second sentence will have what? Channel is to data. Okay. What is the usual window size? It is a hyperparameter. The bigger window size, the more better model we can get. Okay. So don't try to take it as an even number. So again, I told you, right? The left context and the right context should be same. Okay. Now this is my channel is to data is my input features and this is my output feature. Okay. Then again, after this, I will move one more step towards the right. So if I move to one more step towards the right, so how much it is? This is the new context, right? Now, which is the center word? Center word is obviously 2, right? So my next input will have 2. And here I will basically be having is related, okay, data size. Everybody clear? How did we do this independent and the output feature? How we have actually created it. Perfect. Now I cannot slide more forward because I'm not going to get the 5 sentence. But usually in a bigger problem statement, if Google is creating this kind of model, they'll be having a billions and billions of words and sentences. Okay. They can take the entire dictionary or take Shakespeare book and probably try to create this kind of amazing thing. Okay. Now see, what is the aim of Word2vec? Word2vec basically will take this text and based on this output, it will try to generate vectors, right? This is what we are doing. We really want to take the text and generate into vectors. And the vector should be in such a way that the output features that you'll be seeing, it should be almost similar. Semantic meaning should get captured. Semantic meaning should get captured. But still, we are into words. Where is vectors? Krish, you did not talk about vectors. Okay. Now here comes a simple bag of word representation. Okay. Simple bag of word representation. Now tell me, how many unique words are there in this vocabulary? 1, 2, 3, 4, 5, 6, 7, right? If I want to represent Krish, how will I represent? How will Krish vector get represent? Krish. How will Krish vector get represent according to bag of words? Simple. How it will get represented? It is nothing but 1. Okay. How it will get represented? Tell me, someone. It will be 1, 0, 0, 0, 0, 0, 0. Right? So all this will be there. Right? What about the next word? Channel. Channel. Channel will be 1, 1. Sorry. This will be 0. Yes. 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 Okay. So this will be 1, 0, 0, 0, 0, 0. Okay. Then similarly, if you have is, then it will become 0, 0, 1, 0, 0, 0, 0. If it is related, then it will be 0, 0, 1, 0, 1, 0, 0, 0. I hope everybody knows this, right? This is based on bag of words. That is the reason why I'm saying continuous bag of words. So there is some reason why we are doing it. Okay. Now, this data independent features along with the output feature, along with this data representation, will be given to our fully connected layer. What is fully connected layer? Guys, I have taken the community session with respect to deep learning also, right? Fully connected layer basically means ANN, artificial neural network. Okay, artificial neural network. Now in this artificial neural network, the input, how many inputs we have over here? 1, 2, 3, 4, right? All the time we have input as 4. Yes or no? Yes or no, everybody? See, input is 4, input is 4, input is 4. Every time input is 4. Okay? Input is 4, input is 4, right? So whenever input is 4, that basically means we are representing each word with vector of how many words? 1, 2, 3, 4, 5, 6, 7, right? 7 words. So if input is 4, can I say that this is my 7 vector? 1, 2, 3, 4, 5, 6, one more 7. This is 1. This is second. Let me draw this properly. Otherwise, again, people will get confused. So this is my 1. Let's say this is my first. 1, 2, 3, 4, 5, 6, 7. This is my word 1. Okay. Word 1 is represented like Krish is represented by these 7 vectors, right? So in input, I'll be having 1 word, 2 word, 3 word, 4 word. So I'm basically going to have how many number of input layers? In the input, I will be having this many number of nodes, right? 1, 2, 3, 4, 5, 6, 7. Then again, I will be having this 1, 2, 3, 4, 5, 6, 7. And one more word, which is represented by 7, I can have over here. So I will be having this all 1, 2, 3, 4, 5, 6, 7. Everybody clear? So this is my 4 words. This vector will represent word 1. This vector will represent word 2. This vector will represent word 3. This vector will represent word 4. Everyone clear? Yes or no? So in short, in the first instance, Krish will get passed from here. Channel will get passed from here. Related will get passed from here. 2 will get passed from here. Okay. Now coming to the hidden layer. Can you imagine how many nodes will be there in the hidden layer? What is the window size? Window size is 5, right? So window size is 5. So I'm going to basically have another input layer, hidden layer, which will be having 5 nodes. Okay. 5 nodes. This is not 0, guys. This is neurons, hidden neurons. This is input. This is not 0. Okay. This is not 0. These are neurons. If you don't know deep learning, okay. If you don't know deep learning, then sorry. Okay. That is the prerequisite. Okay. These are not zeros. These are neurons. This is the input layer. Okay. When I'm passing Krish, then this value that is going to get passed over here is nothing like this 1 0 0 0 0 0 0. If another word that is going to get passed like channel, then it will become 0 1 0 0 0 0 0. Understand this? These are hidden neurons. Okay, so I've basically written as circle. Okay, it is not 0. Come on. Okay, why 5 neurons in a hidden layer? Because window size is 5. What is the window size we have defined? Window size, what we have defined window size over here? 5, right? So this will be 5, right? Now let's go to the output one, output neuron. Now over here, with respect to output, each word is represented. Output is only one word, right? Output is one word, right? Now when output is one word, that basically means one word is represented by 7 vectors, right? So here I'm basically going to have the output layer, which will be having 7 nodes. 1, 2, 3, 4, 5, 6, 7. Everybody clear? And in the output, we will be using a layer which is called as softmax layer. Okay? Okay? Softmax layer. Everybody clear? Yes? Guys, on the first day only I have explained you what is the prerequisite, right? Harishma, Ashok. Prerequisite in the first day, right? When I'm making a video announcement, at that time only you'll be able to understand things. Okay, fine. Okay. So I hope everybody is able to now understand, right? Now in this hidden layer, now what will happen? Since this is a fully connected layer, every points will get connected like this, right? Every points will get connected like this, like this, like this, right? Then this points will get connected like this. So in short, everything will get connected, right? This is how ANN works, right? And similarly, this entire things will get connected like this, and this entire things will get connected like this, right? So everything will actually get connected like this, and then this will get connected to this, right? Now, if I talk about matrix, this will be 7 cross 5, right? This will also be 7 cross 5. Now, why? If it is connected, that basically means we are going to just have weights initialized over here, right? Why 7 outputs? Because understand, here I have one variable as an output, ease, right? This ease will be represented by a vectors, right? 7 vectors. So 7 nodes in the output. Okay, 7 nodes in the output. Clear, everyone? Yes, yes. Okay, perfect. And again, this will be 7 cross 5. This will be 7 cross 5. Okay. Okay, this will be 7 cross 5, and here also I have something called as 5 cross 7, right? 5 cross 7, because this is 5 and output is 7, right? Now, very important thing, how the training of this ANN will happen. We will initialize weights over here. Everyone will initialize weights over here. So we will always have one hidden layer. Yes, you will have only one hidden layer. Window size can get extended. Only there will be one hidden layer. Okay. Now, over here, you'll be seeing that we'll be initializing different weights. We'll be passing over here. Then from here to here, again, weights will get initialized. And here, softmax layer is there. So we'll be able to solve multi-class classification. Now, what we can actually do over here is that, see this, everyone. Okay. Soon, we come to this, doing the forward propagation, then loss is calculated. How loss is calculated? You know that if I pass, let's say if I'm passing this first input, Krish channel related to. So it will pass, Krish will get passed over here, channel will get passed over here, related to will get passed over here. Then when we go over here, we know what is the output. Output is basically is. Is represented by what vector? This is represented by 0, 0, 1, 0, 0, 0, 0, right? So whenever the forward propagation will actually happen, then what will happen? It will go over here. Then whatever value is there, this loss, y minus y hat predicted will happen. So this 2 will get computed. The difference will get calculated. And again, we have to do the backward propagation by updating all the weights. Okay. So this backward propagation will happen. And then like this, forward and backward propagation will happen unless and until we don't get a loss value very less. Okay. Now, finally, Fine, this is fine. Let's say this, you know that, right? This first value is Krish, right? At the end of the day, how do you represent each and every word? Okay, you know that this first node represent Krish, second node represents channel, third node represent is, related node represent is represented by fourth, right? So how do we know what will be the vector of this node after the training? So it is very much simple, guys. Whatever value, because you know that, right? Over here, whatever 5 cross 7 is there, that basically means this 5 nodes will get connected to this, right? 2, 3, 4, 5, right? So that basically means this node that is representing Krish will be given by 5 vectors, and whatever value will be in this layers, it will be assigned to this vectors. Let's say it is assigning 0.92, 0.94, 0.25, 0.36, 0.45. So this will be my 5 different values of vectors. Since my window size is 5, it will be represented over here. Similarly, for the second node, which will be the 5 one, which will get connected to this, right? Which will get connected to this 3, 4, 5, whichever is getting connected over here, that will basically be represented as my 5 vectors for the next word. Similarly for the next word, similarly for the next word, similarly for the next word. So every time, each and every word will be represented by the 5 vectors because the window size is 5. Okay. Okay. Why 7 neurons in the output layer? It is very simple, because each and every word is represented by 7 vectors. This is represented by 7 vectors. Okay. I hope it is clear, Shalini. Okay. Each and every word is represented by 7 vectors. So it will be shown in 7 output layer. Okay. So those are probabilities values. Yes, it can be probabilities value. It will be the weights value that is assigned over here. So where does embedding layer comes into? Embedding layer will come over here. Okay, so this will be my embedding layer. Okay, in short, whatever weights are there inside this layers, that will get basically assigned. Now tell me, don't you feel that now whatever vectors I'm getting from this training data set will have some kind of semantic meaning, because it is getting trained and the weights are getting assigned with respect to that. Okay, so that is with respect to continuous bag of words. Okay, continuous bag of words, and that is how it is basically represented over here. Okay. Is it always 7 cross 5? It need not be 7 cross 5. Again, it depends on the window size, you know. We can, and how to do the hyperparameter tuning, we can also extend this windows, right? We can extend this windows to any number. Okay. And that is how the entire training actually happens. Everybody clear now? Yeah. If for the people who have not understood, I think you need to revise. You need to know the basics of ANN. Okay. Because here optimizers, here this is there and all. Okay. Everybody clear? Yes. What is strategy to define hidden layers? Strategy is very simple. Whatever is the window size, that will be the hidden layer with that many number of nodes. That's it. Okay. Perfect. Now let's go to the next one. So I hope everybody is clear with the CBOW, and this is how you train the model, and this is how you get the vectors. Okay. I'll show you how to train it from scratch also, and probably in the next class we'll try to see this. Okay. How Word2vec and CBOW is different. CBOW is a type of Word2vec. Now let's talk about the another type, which is called as Skipgram. In Skipgram, only things are changing. Okay. Only 2 things are changing. In Skipgram, what will happen? This will be my input. This column will be my input, and this column will be my output. That's it. Okay. This column will be my input, and this column will be my output. So that basically means in this particular case, my input will be these words like is, then what is the next word? Related to. Okay. Is related to. Is related to. Okay. Window size can be defined through hyperparameter tuning. Okay. And the output will be all these words that you have probably find out at Krish channel related to. Krish channel related to. Okay. Similarly, the next word will be channel is to do data. Channel is to do data, and 2 is nothing but is related data science. Okay. is related data science. Okay. Now, if I'm saying if Google is creating a model of Word2vec with 300 dimensions, can I say in the hidden layer we'll be having 300 hidden 300 neurons in this hidden layer? Yes or no? If you say if Google is creating a Word2vec which is giving you an output of 300 dimensions, can I say the window size is 300? Window size is 300. Yes or no? I can say it, right? So it will be present over here in the hidden layer. It will be having that specific number. Okay. Everyone clear? Now you can actually create your own neural network again over here. So neural network will be very simple over here. If you just have to reverse this neural network. That's it. If you reverse this neural network, you will be getting for the Skipgram. Okay. Perfect. Right. So this was an example with respect to CBOW and Word2vec. Now let's go ahead towards practical. Everybody quite excited with respect to practical? Yes. So let's go and do practicals. And here is my practical. Everyone, yeah. So don't worry if you have not, you don't have to write the code. I will give you this entire code to you so that you can practice over there. Okay. Please focus over here. The library that we are going to use is something called as Gensim. Okay. When to use Skipgram and when to use CBOW? I would suggest, see, both are almost providing the same things. Okay. You can use Skipgram also, you can use CBOW. But again, if you have a bigger data set, I would suggest go ahead and use Skipgram. Otherwise, use CBOW. Okay. Okay. Perfect. Let's go ahead. And first, we are going to install Gensim. So everybody see to this and quickly don't write any code. I will just try to show you, and this code will be given. Okay. Then I'll be importing Gensim, and then you'll be seeing that from gensim.models import Word2vec and keyed vectors. This two we have to basically import. Now understand one thing, guys. Right now I'm first try I'm going to use a pre-trained model. Pre-trained model, Google has actually created this pre-trained model which is called as Word2vec Google News 300. So that basically means Google has trained with its Google News text data, which had more than 3 billion words, and it has created this kind of Word2vec, which gives you 300 dimensions as the output. Okay, 300 dimensions as an output. So here I will show you over here, and by just using this code, I can load this model from the internet. It is somewhere around 1600 MB, so it will probably take some time. So I'm just going to download this. But just make sure that you wait for some time for this downloading. Till then you can hit like, and I'll show you. Once this model will get downloaded, you'll be able to see this. Okay. And again, you can also come up with your own Word2vec model. But again, who has more huge data than Google, right? It is very difficult to come up with a better model other than that DAC. Okay. But I hope everybody is liking this session, whatever things I have explained you today. Yeah. Yes, the output has 300, not the hidden layer. Hidden layer will have 300 neurons, right? Window size of 300. Yes, it is 300. You can consider in that way. I don't know about the input size, but definitely you can understand. Okay, window size, you can basically say, okay, 300 and the middle word is taken and the context word is basically there, right? So it will probably take some time, 167 MB. And this is how it will happen. Just wait, let's wait for some time, and we'll have much more information going ahead. Okay. Yes, you can join the full stack data science course anytime. So it's about understanding things, guys, because anyhow you're going to use some models to do all these things. So not a big deal onto that. We'll wait for some time till everything's get downloaded. 20% is there, right? Hit like. Let's make it some like. I know this is a very important session, I can say, but people are not interested to join. Can't help. Okay, I can't force people to join. But I will teach in this way, and I hope your learning is quite good, going on good, right? DL community is also going on live. Which DL community? Which DL community, guys? Have you teach GPT-3? I'll teach it. We'll come to BERT, transformers, RNN. Then also we'll be learning about embedding layer, right? What does cosine similarity gives? How similar those two words of vectors are, What's next to what W2vec? Tomorrow we'll be doing practicals related to it. We'll create our own Word2vec models. So till here, I think we have covered many things, right? So I like all these things, right? It is so good to understand, when you understand why it is getting used, how it is getting used, So it's quite amazing. Okay. Glove also I'll complete it. Okay. Yeah, this 15 day sessions are enough for NLP interviews, right? But you have to create a lot of end-to-end projects. At the end of the day, see, by using a deep learning model, how you are able to quickly create and things, right? So let's wait for some time. I think the model is, yes, I'm there. If this much time it is taking for downloading, what should I do, right? Yes, guys. Thank you, Vedyo, for the super chat. Guys, yes, please make sure that you do super chat and all so that I can invest this money on you all. Okay. I can give this money directly to you by giving this kind of quizzes and all, right? It'll be amazing. So, can we see quickly in 5 minutes what we saw till now? Sure. Till now, what all things we have actually discussed. We discussed about word embeddings, Word2vec, CBOW, Skipgram. We understood the architecture. What was word embedding we have actually taken, right? What is feature representation? How Word2vec actually creates this? How is this feature actually created? I showed you with the help of a dataset example, right? So everything is basically getting created over here, right? Yeah, end-to-end projects also I'll do it, guys. एक ही तो घंटा है कितना कर पाऊंगा. They say that. So 54% is done. Probably another 4 to 5 minutes it will be completed. Okay. Anyhow, let's wait. Once this is done, you'll be able to see amazing things. Okay. See, I'll show you till then. Let that get downloaded. So here you can see, right? When I take a word of king and probably see the vectors, this is nothing but 300 dimension words, right? 300 dimension words. See this. 300 dimension words, right? Vector of king, right? Similarly, if I go and see next, what is the vector of man? Here you'll be getting 300 another dimensions. Okay. So here also you'll be able to see another dimensions. Okay. There is also a method which is called as most similar vectors. Okay. So if I give man over here, so what it will do, internally it will convert that into vectors and it will show you what all cosine similarity or similar words are there. With respect to man, you can see woman is there, boy is there, teenager, girl, and how much this basically shows you cosine similarity. Okay. Okay, so here you can see that here you are actually being able to get it. Okay. Yes, this is 300 window size. That only I told you, 300 window size. Okay. Now see this. If I try to see what is the most similar word to king, right? Here cosine similarity is used internally with respect to vectors. So I'm getting king again, then queen, monarch, crown prince, prince, sultan, ruler, princess, prince paras, throne, right? Is it amazing, guys? If you want to find out the cosine similarity also, you can use another method which is called as similarity. How man and king are similar. It is saying that it is similar to 0.22. Not correlation, guys. Cosine similarity is completely different. Cosine similarity basically means angle between the vectors that you are trying to calculate. Okay. So here you can basically see wv.similarity with respect to HTML and programmer. Here you can see that if I'm searching for programmer and HTML, it is 0.25% related. Right? Then Here also you can see word to cloud. See, this is word to cloud. Okay, word to cloud. If I convert this dimensions into two dimensions and probably plot it in this graph, you'll be able to see this kind of word to cloud. Okay, I think you've seen this in Mentimeter also, right? So let it download and let me just show you. It'll make sense. So another 17%. Will you teach how to build models using this feature tomorrow? Yes, Vivek. Tomorrow I will be teaching that also. We will train our own Word2vec. Okay. Sir, can we limit the window size in Word2vec pre-built model? Yes, we can also do that, but you have to train your own model, right? But always understand, if I keep the window size more, right, we will be able to get amazing models. We'll be able to see that difference, right? That is a kind of hyperparameter. Again, we can play with it. It should not be overfitting, but yes, it should give you a good words. Till then, please go ahead and subscribe Krish Naik Hindi channel, because I also upload data science videos over there. Guys, Krish Naik Hindi channel, just search for it till the model gets uploaded. Okay. You have to give me opportunities, then only I will be able to give amazing giveaways for you, right? Tomorrow also we are going to have a session. There also I have to give you 5,000 rupees, right? So it'll be amazing. Search for Krish Naik Hindi channel and subscribe. Subscribe Krish Naik. Okay. Code I will give you in the dashboard. You'll be able to see it. I will give you this link. You want this link? Let me give you this link, then you can execute it. अभी देख लो, मैं बाद में लिंक भेजता हूँ. ओके, बाद में लिंक भेज देता हूँ. Thank you guys, already subscribed. People are saying thank you. Okay, done. 100% about to get completed. Some ending is things are happening. Okay. Guys, still it is taking time. Come on, come on, come on. Come on, my friend. Happen quickly. Can you mention the required specs of laptop? i5, i7, Google Colab is there. You can definitely use it. I have an amazing desktop altogether. That paid membership is just to support me, because of uploading videos and all. I upload a lot of videos, so okay. Let's see. It is taking time. I don't understand why it is taking time. File was okay. So, but I hope you have understood what I'm actually trying to do. And if you do this kind of competitions also, right? W of V king minus W of V man plus W of V woman, you'll be able to get the answers, which is like queen and all. Also, you'll be able to get it. Okay, it is taking time. I don't know why it is taking time, but something is happening over here. I have to keep this ready. I don't know. I'll just reload it, let's say. Okay, again I think it will cry and it will take time. It's okay, guys. It shows busy anyhow. Let me just show you in tomorrow's session if possible. Okay, and we'll try to do it. It's anyhow 1 hour is done. So let's do one thing, is that let's try to participate in quiz till then, if this is not working. But anyhow, let me just do it tomorrow if possible. Okay. No, everything is correct because I ran this and all. Okay, over here I think it is showing some problem with. I think I have opened Google Colab somewhere else. Hey, code ran, huh? Just a second. Now I think it ran. I hope so it ran. Yay! Hooray! Okay, it's running. Perfect. Let's go ahead. So here you can see I have taken vector underscore king. Okay. And here you can probably see all these things. Okay. Now you have all these 300 vectors. Okay. The code got deleted. Huh? Okay. Okay. So if I write WV, see WV is my model. Okay. If I write WV dot, let's see, there is something called as similarity is there, similar by word is there. If I write similarity with some word like cricket, and if I execute, let's see, similarity is missing one positional argument. Okay, just a second, not a problem, I will fix this issue. Just a second, guys. Just a second. Okay. Most similar. Most similar. Let's see with respect to cricket what all things you actually get. There's some inbuilt functions which you can basically use. Most similar to cricket. But always, all the time, it will be giving you 300 dimensions. So, say for cricket, it is like cricketing, cricketers, test cricket, 2020 cricket. This is there. Okay, and if I again use WV dot most similar to happy. Okay, to happy again, you will be getting some similar words like glad, pleased, ecstatic. Now, see, you can find out the semantic meaning over here, right? The main semantic meaning you are able to get over here, right? So this is quite amazing. Okay, there is also something called as similarity. So here I'm going to basically write w dot uh, most similarity or similarity is there, no? Similarity is there. I can basically also compare two words and find out how similar it is. Cricket, let's say, and here I'm going to write sports. Okay, so here you can see it is 40% similar. So yes, obviously cricket is a sport. I can also use hockey, right? I can also use, so it is 53, right? And I can also write something like this. Let's see, WV of king, okay, minus WV of queen, no queen, man, plus WV of what it is, WV of woman, right? Woman, singular it is, right? So let's make it. So this will be my vectors. Okay. So here you can see that again, this vector will be 300 dimensions, right? So if I probably see this, this will be 300 dimensions. And now what I can do is that I can basically write most similar to this vector. So here you will be able to see this output. Most similar, I think, to this vector, it will work, I guess. Okay. Vector, I think you have to give a word. I think there is also something like, let's see whether there is something like models or something like that. Just give me a second. I'm just checking out the documentation, what function it will be present over here. Okay. Most similar it is. And here we have to give in the form of list. Then I think we'll be able to get it. So you can see I'm getting king, queen, monarch, princess, crown prince. So it is being able to capture it easily, right? So yeah, in tomorrow's session, we'll try to see some more things, related to it. And let's see how things will go ahead. Tomorrow, we'll be doing some other problem statements. Now, without wasting any time, okay, I will just first share this. Please make sure that all these materials will be shared. Okay, in the description you have that entire community dashboard link. So let me go ahead and let me quickly start this present. Okay, so first thing is that you have to follow me in Instagram so that I can get your ID card and you can basically start participating, right? I will be taking live sessions, yes, definitely, on computer vision also one or the other day. So quickly go ahead, make sure that you follow me in Instagram, keep your ID card ready so that you can send me your ID card if you are the winner, right? So everybody, you can follow me so that in the Instagram so that I can actually see your QR code is not visible. Okay, go to menti.com, no, if possible. Go to menti.com, or should I give you the link? Okay, the link is given in the chat. Okay, go to the link that is given over there, right? Don't forget to follow me in Instagram, then only I will be able to give you. Go to Naik 06, follow over there, then only you will be able to send your ID card and I'll be able to verify. Okay, please do that specific thing before we start the quiz. Now guys, one super cool assignment for you is that I would suggest try to use any kind of data sets and try to apply the Word2vec that is actually present. Okay, everyone quickly get into it. And I've seen a lot of assignments from people who have submitted yesterday. It was quite good. That is very nice. Please make sure that you submit assignments and you participate in things, right? So please make sure that you follow me over there in Insta so that I will be able to see you. Okay, another 1 minute and then I'll start the session. You can give any ID card, not a problem. So that, and also make sure that at the end of the day, whatever rank you're getting, okay, if you are in the first top 3, take that screenshot and send it to me. Okay. Perfect. 198 have joined. Come on, quickly, guys. 350 people are watching. Hit like, make it 300. Okay. Okay, till then, I will add the dashboard link in the description of this particular video. The community dashboard, you can actually check it out. Just a second. I will add the community dashboard link so that you will be able to find the materials there. Okay. Community courses. This is NLP community. Okay, NLP community link. I will try to add it in the description. All materials will be added in the below dashboard. Enroll for free. You don't have to pay anything over here. Enroll for free. So you'll be able to find out the dashboard link in the description of this particular video. I've updated it. Please check it out quickly. Right? Check it out, guys. Quickly reload the page. Just reload the page and check it out. Quickly reload the page and just give me a confirmation whether you have got the dashboard link or not. Okay. So just give me a confirmation whether you have got the link or not, guys. Just reload the page quickly. And in that dashboard, we will upload it, all the materials within some hours. Okay. Okay. Enroll in that dashboard and you will be able to get it. Okay. Okay, 231. I think other people are not interested. Let me go to the next step now. Everybody joined or still joining? Everybody joined or still joining? Joined? Shall I continue? Shall I start? Okay. Go. Which city do you belong to? Go and write the city name. Mumbai, Pune, Jaipur. Word to cloud is happening. I showed you this word to cloud, right? Just a while back. This is again a concept of Word2vec. Okay. Hyderabad, Bangalore, Pune. Come on, come on. Bangalore is the highest right now. Hyderabad, Pune, Noida, Chennai. Any people from outside India? I don't see many people outside. Okay, Düsseldorf is there, right? Okay, join, guys. 300 people are joining. Shall we go ahead? So I hope everybody has written it. Let me go ahead and best of luck to everyone. And here we go. So the first quiz in your screen is going to come in another 5 seconds. But here you can see you have got your own avatar. Please make sure that you write your name. And here we go. I'm pressing enter. So coming the first question on your screen. In word embeddings, a vocabulary of 500 words will have 500 dimension vectors. True or false? So 5, 4, 3, 2, 1. A very simple question to start with. Okay, perfect. Let's go with the next question now. Coming to the second two. Second question on your screen now. Tell the one hot encoding vector for the word in vocabulary Krish subscribe Krish channel when binary is true. Quickly, guys, come on. Perfect. 1010. Many people have said it right because Krish will become 1, subscribe will become 0, Krish will become 1, and channel will become 0. Perfect. Everyone, this is amazing. Let's go to the next question quickly. Before that, let's go to the leaderboard. Who is in the first position? Raja Varun. Second, Manish V. Third, Adarsh. I think absolutely people are doing fine. Okay. Raja Varun is the first. Manish is there. Okay. And let's go to the next question, everyone. Question number 3. Word2vec can be a model that can be trained from scratch, pre-trained model, both, none. I hope this should be a very easy answer for every one of you out there. Yeah, I guess many people are participating in an amazing way. So time's up. The answer should be both. This I have already explained you. So 241 people have said right. 34 people said pre-trained model. I think they were not listening to the entire lecture what I said. But yes, it can be trained from scratch. And it can be a pre-trained model and it can be both. So coming to the next question, which is your fourth question on your screen. And here we go. CBOW and Skipgram can be trained with convolution neural network, recurrent neural network, fully connected layers like RANN and LSTM-RNN. Another 20 seconds to answer this question quickly. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. So amazing. People have said it right. Fully connected layers like ANN. And again, I have explained you just now, just a while back. Okay. CBOW can be trained with. Okay. Convolution neural network will not give you a good error, good accuracy. Okay. So again, let's see who is first now. Raja Varun is still in the first, Adarsh second, Anmol Soin third. Okay. Perfect. Let's go to the next question. Here we go with respect to question 5, and I think this is Word2vec is good at. Okay. Capturing semantic meaning, image classification, reducing sparsity, and reducing dimension, both 1 and 3. Time's up. So both 1 and 3 is the right answer. People have missed reducing sparsity and reducing dimensions. I've already explained you over there clearly. 173 people have heard it right. And some may be in very hurry to answer the question. Okay, now let's start this. Still, Raja Varun is in the top. I think he can be an winner right now. Okay, we don't know because now we are going to have some Python sessions. Okay, Python programming is also going to be included. So here we go with respect to your Python question. What is the output of this code? What is the output of this code, guys? Come on. So the third output is right. The program will execute with error. Please try it out. You cannot append two values at one time. Okay, you have to put it in a collections. Okay. So definitely for the people who have said it right, that's amazing. For the people who have said it wrong, you're confused. Okay. Let's go to the next question, the final question of the day. And again, it is a Python programming language. Here we go. What is the output of the Python code? 25, 125, 25, 100, 25, 150, 25, 625. I hope many people should say it right. Amazing. Okay. So 205 is the right answer. Now let's go to the leaderboard quickly and see who's first, second, third. You can drop me a message along with the screenshot, everything. Okay, Raja Varun, I think he's the winner, I guess. So Raja Varun is the first winner. Then we have Anmol Soin. Then we have Shubham Sarkar. You can directly ping me in the Insta, guys, quickly. Ping me in the Insta. Okay, Anmol Soin done. You can send your photo, Anmol. Okay, Anmol has been the second winner. 2 times he has actually won. Okay, 2 times. He's basically coming to participate in quizzes. Nice. So again, I have to send him 1500 rupees. Let's see. Okay, same winner. Quiz winner 1500. Here we go. Other people, you can send your Anmol. I've already sent it. What about other people? Please drop me a message. Shubham Sarkar. Okay, Shubham Sarkar, please drop me your ID. Please drop me your ID, Shubham. Shubham is in the third reward. So Sir ji, it was a really hard competition. Shubham also gets 1500. Quickly, I will send him. I know, guys, rank will get improved. Don't worry. What about Raja Varun? Raja Varun message I did not get. So, Shubham also money has been sent. Raja Varun. Raja Varun message I did not get. Raja, if you are not in Instagram, please drop me a mail at krishnaik06 at the rate gmail.com. Okay. Shubham Sarkar says, got it. Perfect. Raja, you can drop me a message or mail if you don't have Instagram. Okay. Increase to 10 questions. Sure. From next time I'll increase it and I'll put random things now. Okay. I'll not keep quiet at one thing. Okay. Please make sure that you follow me on Instagram so that you'll be able to participate in a better way. Okay. Okay. So Raja, if you don't have Instagram, please कोई तो विनर लोग वापस डोनेट किया करो, दूसरे का भी भला हो जाएगा. So difficulty level. This was simple. I will try to keep more difficult. Okay. See, this was some of them were tricky. Okay. Some of them were tricky. So you cannot just say that it was very easy. Okay. But definitely from next time I'll do it. Okay. So I hope everybody liked this session. Please make sure that you subscribe both the channels, Krishna Hindi channel. And yes, this was it from my side. I'll see you all in the next session. Keep on rocking, keep on learning. And yeah, I'll see you all in the next session. Till then, bye bye. Take care. Thank you, guys. Okay. And Raja Varun, what you can do is that you can just drop me a message either through mail or something. I will try to give it to you. Okay. If you are not in Instagram, it's fine. Okay. So thank you, everyone. Bye bye. Take care.